Good morning, class. Make sure that today you turn in 5.2.1, the lesson that we started on last week. You should have a sequence, a table, and a graph for each member of each function family group. And you have perhaps two, three, or maybe even four different groupings of those functions. Make sure those get submitted. Also, tonight, review preview questions 51 through 56. Today in class and today during the morning time, your class time, either in class or away from class, we're going to quickly go over the recovery quiz. There's 9 questions here, and then I'm going to assign you some extra practice. It's a good time to do this because the Chapter 4 test is this week. Most of the items that you see here on this page are going to be part of the Chapter 4 test, right? We keep seeing these things come up again and again. The first 2 questions ask us to simplify an expression. You can see this expression, number 1. It says simplify. This is kind of the art of rewriting something, and that's a very good technique for solving equations. Perhaps this expression could be part of a more complex equation, and being able to rewrite it in a simpler form may make it more likely that I'm going to be able to deal with the equation that it lives in. The goal, of course, is to write something that's exactly the same. I want something that's simpler to deal with but has the exact same attributes of the thing that I'm starting with. One of the things I see immediately is 9 over 18. That is the number 1/2. If that's difficult for you in any way, if you're not sure how to rewrite that so that you can see the giant 1 and get rid of the common factors, see me, because your calculator will easily do that task, and I'd rather have you offload the arithmetic with fractions than not be able to focus on the algebra. So let's focus on the more complex part, the part that I have here, a squared over a to the negative 7th power. Any number times its reciprocal equals the number 1. So when I take and I multiply a to the negative 7th times a to the 7th, that equals the number 1. I know that in 2 ways. If I add negative 7 plus 7, I get 0. A to the 0 power is 1. But also I could just think more generally about what are reciprocals, right? If I have 3 times 3 to the negative 1. If I have 12 times 12 to the negative 1, right? If I have something times its reciprocal, and that's what negative exponents are, right? That's what's happening here. I get the number 1. So I selected to multiply that denominator by a to the positive 7th power because that turns this chunk into the number 1. However, I've definitely messed up this expression and I've changed it from the original expression. In order to fix that, I'm going to multiply my numerator also by a to the 7th power. Multiplying by this number 1 does not change the nature of the expression I started with. It's exactly the same. In my numerator now, I have exactly 9 factors of a. A to the 2nd times a to the 7th is a to the 9th power. And you can write your answer like this, or I think a more compact and preferred form would be a to the 9th all over the number 2. Let's look at question 2. In question 2, in my numerator, I see 3 times 9. I was going to say C3 and then PO is going to come out, but I see 3 times 9, which is 27, and in my denominator, I see the number 81. Well, guess what? That's the number 1/3. If you can't see that in terms of giant ones, if you can't see that in terms of eliminating common factors, talk to me and I'll show you exactly how you can quickly, efficiently reduce any fraction on your calculator and identify this as correctly 1/3. The other thing that I have here is in my numerator, I see I have a squared times a to the 6th, which is a to the 8th power. And in my denominator, I'm sorry, I'm saying a, but these are x's. In my denominator, I have x to the negative 8th power. Do not be tempted to think that these are going to cancel each other out. They are not. They will not eliminate. This is not equal to 1. The numerator and denominator are different things. If the numerator and denominator were both exactly the same, a to the 8th, this would equal 1, but that's not what I have. So what I choose to do again is multiply my denominator by x to the 8th power. That is a number times its reciprocal. That equals the number 1. That is x to the 0. Anything to the 0 power equals the number 1. I have changed the nature of this fraction though, so to fix that, I'm going to multiply the numerator also by x to the 8th power. Again, big idea, multiplication by 1 doesn't change a thing, it just changes the form the thing's in. At this point now I have x to the 16th power in my numerator, x to the 16th power, and in the denominator I have the number 1. That means my answer for this problem would be either 1/3 times x to the 16th power, or I think the more preferred way to write this would be x to the 16th over the number 3. Again, please appreciate what you've done. You've taken complexity in this particular monomial and you've reduced it so that now this is something easier for us to deal with. Number 3, solve for x. There's a beautiful example of a solving technique that we call Fractionbusters. I can multiply both sides of this equation by something so that all of the fractions go away. Please do not disregard the x. Some of you are leaving the x in the denominator and then claiming that the x somehow is magically in the numerator. If I want to get rid of these fractions, I would choose to multiply both sides and all terms on both sides by 2, 3, and x. When I multiply both sides and all terms on both sides by 2, 3, and x, magical things happen. First of all, for that first term, when I multiply by the 3x, I want us to notice that the denominator has 3x. Those are common factors. They're gone, and I'm left with just the number 4. Yep, it's just the number 4 now. The next thing I want to notice is that if I multiply the next one by 2 times 3 times x, I'm noticing that there is a 2 in this one's denominator. You see it, there's a 2 there. And if I multiply that fraction, I end up getting 3 times 5 times x, or 15x, plus 15x. The 2's are gone, it was a common factor. And then finally I see that I'm going to multiply the 4 also by the 2, 3x. 4 times 2 is 8, 3 times 8 is 24, so I'm left with this equals 24x. If I subtract 15 from both sides, I get that 5 is 9x, and if I divide both sides by 9, I get that x is 4/9. 4/9 is the value of x. There we go. And of course, if you do not know how to check this on your calculator, please talk to me. I'm happy to show you how. But you can easily enter 2 divided by 3 times 4/9 properly in your calculator, plus 5/2 and see that it does give you indeed the number 4. To solve this expression with the square root, my goal, first of all, is to get the square root part of this equation and completely isolate it. That means I want all of this to be written so that it is completely alone and by itself. If I look at that, I can see, undoing is going to be a beautiful tool to isolate the square root of 4x minus 3. I'm going to begin by adding 5 to both sides. This becomes 6 times the square root of 4x minus 3 equals the number 30. Again, I'm reminding myself I am isolating the square root of 4x minus 3. I cannot push across this a factor of 6 and think that it's equivalent. I can't do that. I cannot distribute the 6 within inside the radical. Not the 6 anyways. But I can divide both sides of this by 6. If I divide both sides of this equation by 6, I'm left with the square root of 4x minus 3 because I divided this side by 6, and on the other side that equals 5. The only way that the square root of something equals 5, the only way that the square root of 4x minus 3 is equal to 5 is if 4x minus 3 is equal to 5 squared, right? If it's equal to 5 squared or 25, this would be true because the square root of the blue thing, the square root of 25, would give me an answer of 5. So I come over here and with that looking inside thinking, I write 4x minus 3 must be the value of 25. I can now add 3 to both sides and get that 4x must equal 28. And if I divide both sides by 4, I get that x must be the number 7. When x is 7, this top expression is true. 4 times 7 is 28. 28 minus 3 is 25. The square root of 25 is 5. 6 times 5 is 30. And 30 minus 5 is indeed 25. Moving on to question 5. Question 5 asks me to find the equation of the line that has two properties. One of the properties is that it has to make a right angle to this line. This is a line. I want the equation that makes a right angle to it. Why? Because I'm looking for the one that is perpendicular to that line. A right angle. And the other property is that it must go through this point. So if I'm thinking about a picture of this, somewhere there's a line, somewhere there's this point, and I want to draw a line through this point that hits this line at a right angle. Fun to look at on Desmos, fun to do. You can easily see what you're trying to find, and you can also test out if you're correct or incorrect using Desmos. I'm going to do this by figuring out the slope of the line that I'm given. The reason why I want to find the slope of the line that I'm given is I know if I have the opposite reciprocal of that slope, I would have the slope that would make a right angle or be perpendicular, right, to that line. So to do that, I'm going to subtract 4x from both sides. I get that 6y is equal to negative 4x plus 18. And now I'm going to divide both sides by 6. Y equals negative 4 over 6 times x plus the number 3. I see a slope. The slope is negative 4/6. That's the same as negative 2/3 if I reduce it. If you have a difficult time reducing fractions like that, talk to me. I'll show you how to do that on your calculator. Any line that is perpendicular to this line would have to have a slope that would be the opposite in sign. This one's negative, so I make it positive. And reciprocal. This is 2/3, so I'm looking at 3/2. A slope of 3/2 is going to hit a line with a slope of negative 2/3 at exactly a right angle. So I'm dealing with this slope, but it has to go through this point. The question is, what's the y-intercept? To answer that question, I think about the equation of the line written in slope-intercept form. Y equals mx plus b. I have a y value. The y value is 7. I have a slope. The slope is 3/2. I have an x value. The x value is 10, and I write plus b. 10 divided by 2 is 5, times 3 is 15. This is 7 equals 15 plus b. If I take away 15 from both sides of that, I get negative 8 is what b must be. At this point, I have both the slope and the y-intercept, so I can write my answer. The equation of the line that I'm looking for is y equals 3/2 x minus the number 8. As a quick check, I notice that the equation I wrote does have a slope that is opposite reciprocal of the line that I was given. That's a good thing. Also, I notice that if I put 10 into that equation, 3/2 times 10, 10 divided by 2 is 5, times 3 is 15, 15 minus 8 is 7. I notice that when I put 10 in, it gives me 7 back. Perfect. Wonderful. Let's move on to question number 6. Question number 6, we're asked to multiply a binomial times a trinomial. I'm going to use an area model because it helps me organize my work. My area model is going to have 3 columns because I want to model a polynomial with 1, 2, 3 terms. My 3 terms are a positive x squared, a positive 2x, and a negative 5. And I'm multiplying that by a binomial. A binomial has 2 terms, and the 2 terms are 3x, positive, and negative 1. Inside of each one of these, I'm going to find the products of multiplying the thing above, the thing above, the thing above, by the thing off to the right, right? Every single time, the thing above by the thing to the right, the thing above by the thing to the right. So let's begin. When I multiply 3x times x squared, I get 3x raised to the 3rd power. When I multiply 3x times 2x, I get 6x squared. And when I multiply 3x times negative 5, I get negative 15x. Down below, same exact thing, except this time I'm going to be multiplying negative 1 by each of these 1, 2, 3 terms. Multiplication. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times 5, negative 1 times negative 5 is positive 5. Yes, it is. It's positive 5. In this entire expression, there are two collections of terms that I can combine. I clearly see them. The 6 times x to the second power and the negative x to the second power are like terms. They can be combined, and also the negative 2x and the negative 15x may be combined. My answer is the product of these binomials. The product of those binomials is 3 times x to the third plus 5x squared, because I took away 1 from the 6, minus 17x because I had negative 15 and I subtracted 2 more, and then plus 5. Question 7. Question 7, I see the 1/2 and I see the 1/8, and I am immediately thinking, hey, let's go ahead and use a base of 2. So again, the only tool that we have for solving an exponential equation, and this is exponential, I say that because it's an equation in which my variables live in the exponent. The only tool that we have at our disposal in Math 1 is to change the bases so they are the same. If I look at the number 1/2 and I look at the number 8, I'm thinking, there's a lot of 2's rattling around in those. In fact, 1/2 is the same thing as 2 to the negative first power. Yeah, I just rewrote it. It was a 1/2 and I wrote it as 2 to the negative 1. Can I do that? Absolutely. They are exactly the same thing. 2 to the negative 1 equals the number 1/2. On the other side, I've got 8, which is exactly 2 to the third power. 2 times 2 is 4 times another 2 is 8. And I'm raising that to the x plus 2 power. If you're not sure where to begin, take a stab at it, look at them and think, and sometimes it's helpful to write powers of the base you're dealing with. I could write 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and I can think about these. This is the number 8. This is the number 4. This is the number 2. This is the number 1. As I go down this list, I am dividing by 2 each time. When I hit 2 to the negative 1, that is, surprise, surprise, 1/2. So you can see the reason why I'm using these is because I'm replacing 1/2 with something that it equals, and I'm replacing 8 with something that it equals. Now that I have a power raised to a power, you can see it, it's a power. It's 2 to the negative 1, and I'm raising that to the 3x minus 1. I can simplify this by multiplying this power, negative 1, times this power. And I'm making sure I get the whole thing. I can multiply this power, 3, times this power, and I'm making sure it hits the whole thing. This becomes 2 to the negative 3x plus 1. This becomes 2 to the 3x plus 6. That's a beautiful thing. It's a very beautiful thing, because now I have an equation, an exponential equation, in which my bases are identical. They're both the number 2. So I can rewrite this by setting those bases equal to each other. The only way this is solvable is if negative 3x plus 1 is exactly the same as 3x plus 6. Then and only then will these two expressions be equal to each other. I'll solve this by adding 3x to both sides. That gives me that 1 is equal to 6 times x plus 6. And if I subtract 6 from both sides, I get negative 5 is equal to 6 times x. And then as a final step, I divide both sides by 6. Negative 5 over 6 is what x is. X is negative 5/6. Question number 8, I'm asking you to rotate this shape about the origin, that's the spot 0, 0, and then give the coordinates of A prime. If you ever need a piece of patty paper to help you visualize that, please let me know. I have some in the classroom. But I know that if I rotate things 180 degrees about the origin, it doesn't matter if I go clockwise or counterclockwise. And I also know that the rule will always be any xy is going to go to the point where I'm looking at the opposite of x and the opposite of y. x and y becomes negative x, negative y. So I'm just flipping the signs. I'm just switching the signs. If I look at this very first point right here that's at negative 1, it's going to go to the point positive 1, negative 1. If I look at this point right here that's A is at negative 2, 2, it's going to go to 2 and then negative 2. There's the A. In fact, that's part of my answer. I need to write that down. If I look at the point that's at negative 2, 3, it's going to go to 2 and then negative 3. That point's going to go right there. If I consider the point that is at, let's use this color, negative 3, 3, negative 3, 3 is going to go to 3, negative 3. At this point, I can pretty much see what's happening. I think I can fill in the rest of it, but I'll add one more point. Let me do the one that's at negative 5, 1. That's going to go to positive 5, negative 1. There it is. I've got all the points, well, except for one. I can now sketch the polygon after the transformation occurs. It's going to live right here, right here. This is it. And furthermore, A, the green dot, lives at the point A prime is going to be at 2 comma negative 2. And then finally in question number 9, we're asked to find the equation of a line that goes through 2 points. I need to figure out what the slope of the line that goes through these 2 given points is. And to figure that out, I'm looking at how much my y's value changed. That's the up and down, the rise. That's the change in y. And I can just go 9 minus 1 is my change in y. And for the change in my x values, that's the left and right. That's how much the x values change. I'll go 4 minus 6, which is negative 2. So I end up with 8 over negative 2. And 8 over negative 2 is negative 4. I now know one of my 2 parameters for this line. I know my slope parameter. It is the number negative 4. Now to find my y-intercept parameter, I'm going to arbitrarily pick this point right here, and I'm going to write that 9, which is y, equals m, which is negative 4, times x, which is positive 4, plus b. You can see what I did. I took the y value from this point and the x value from this point and the slope that I found earlier. So I get the equation that 9 equals negative 16 plus b. And if I add 16 to both sides, I get that 25 must be the value of b. 9 plus 16 is 25. I now know both parameters. I know the slope parameter and the y-intercept parameter, so I can write y equals negative 4 times x plus the number 25. Both of the points that I see on this screen will work when I plug them in, and that's a great check. When I plug in 6, I get 1, and when I plug in 4, I get 9. Now complete the linked assignment in Microsoft Forms. You will need to use your school account to log in. And please, the idea here is you practicing. You can use PhotoMath, I don't care, but if you do that, you're not practicing. And guess what? When you come in to a baseball game, if you haven't been in a batting cage swinging at the ball a lot, you're not going to hit it. Or the chances you're going to hit it are very small. So get into the batting cage, start swinging at the ball. Don't use PhotoMath because that's not what we're supposed to be doing. And have fun. Talk to you later online and in class.